programming pipelines offer an incredibly expressive way to solve complex combinatorial problems. On platforms like ASP Chef, users can compose these pipelines by chaining modular functional blocks called ingredients. However, orchestrating these pipelines still requires a steep double learning curve. Developers must master both formal ASP syntax and the platform's specific ingredient library. In our paper, we introduce ASP Sous-Chef, a system featuring two complementary large language model extensions designed to eliminate this barrier while maintaining strict token efficiency and logical correctness. The first extension is the Advisory Assistant, which provides context-aware guidance in real time during recipe authoring. Rather than relying on a static, broad system prompt that exhausts the LLM's token window, the advisor utilizes an on-demand retrieval protocol. When a user asks a question about data flow or visualization, the platform detects the intent, runs a background document retrieval sequence, and supplies the precise documentation for relevant ingredients, such as this.js network, directly into the inference context. To ensure adaptability to different hardware and data privacy requirements, the Advisory Assistant operates in two configurations. The local version runs entirely on the client side inside the browser. By leveraging WebGPU and the MLC compilation framework, it performs private hardware accelerated inference directly on the user's machine. For users seeking higher throughput reasoning or specialized models, the remote version seamlessly connects to external endpoints, including local Ollama background instances or rapid inference Groq APIs. While the advisor provides passive guidance, our second extension introduces an autonomous agentic interface built on Anthropic's Model Context Protocol, MCP. By establishing a server-sent events bridge between the web platform and an external LLM client, ASP Chef exposes its Workspace mechanics as a collection of discoverable JSON RPC tools. As you can see, the external agent dynamically reads the Workspace state and manipulates the pipeline autonomously. The MCP server exposes tools grouped into three primary capabilities. Discovery tools, such as getRecipe, allow the agent to inspect the current active pipeline architecture. Manipulation tools, like add operation and edit operation, give the agent the authority to programmatically place, wire, and modify ingredients. Knowledge tools, such as list ASP skills and load ASP skill, allow the agent to query a library of predefined logical reasoning templates, such as Hamiltonian path or graph coloring patterns on demand, keeping its core instruction window lightweight. Automating visual workspaces with LLMs introduces significant engineering challenges, particularly regarding context synchronization. If an agent applies multiple workspace modifications sequentially based on outdated pipeline states, index shifts will break the layout. To enforce structural consistency, our framework implements an index safety invariant. The system structurally mandates that the agent must invoke a discovery read operation right before executing any manipulation command, ensuring it always coordinates with the absolute latest state of the recipe. By marrying the flexible natural language capabilities of LLMs with the absolute mathematical precision of the underlying ASP solver, ASP Sous-Chef creates a reliable neuro-symbolic workflow. The AI agent manages the scaffolding, parameterizes the tools, and structures the front-end presentation layer, but the rigorous declarative reasoning remains strictly enforced by formal logic. The full open-source implementation, fast MCP configuration schemas, and deployment instructions are available in our repository. In this practical walkthrough, we will show you exactly how to configure your environment for both remote advisory assistance and autonomous agentic orchestration. Let's begin with the remote assistant. The first step is to visit the Groq Developer Console. Sign up for a free developer account, generate a secure API key, and copy it. Back in ASP Chef, paste your key into the AI settings panel. To protect your data privacy and maintain full transparency, our architecture implements an explicit opt-in policy. Whenever you deploy a remote assistant ingredient, the interface will formally prompt you to authorize the use of your API key for that specific session. Now, let's step up to our advanced agentic architecture powered by Anthropic's Model Context Protocol, MCP. This allows an external AI agent to read your pipeline context and actively modify code blocks for you. To set this up, we will clone the official repository from GitHub. Next, we need to declare this tool directory to our agentic client. In this demonstration, we are utilizing the GitHub Copilot CLI platform. Open your configuration file and register our local Python server. With just a few integration steps, you have an intelligent, safe, and collaborative neuro-symbolic coding kitchen. Thanks for watching and happy cooking with ASP Sous-Chef.